Hi, Mr. Steger here. We're going to start the first of 4 activities, our quivers, with chemical weathering. This is going to be for the erosion and weathering material that we'll be covering at the beginning of the year. First of all, what is chemical weathering? Well, we're looking at how the environment changes, how rocks change, how they get broken down. One of the types of weathering that does this process is called chemical weathering. In chemical weathering, there are chemical reactions that break down the bonds holding rocks together, causing them to fall apart, forming smaller and smaller pieces. What this means is basically there's a chemical reaction going on that takes the molecules and the compounds that make up different rocks, and it makes them into smaller pieces. Chemical weathering is much more common in a location where there's lots of water. Water is considered by many to be the universal solvent. And what that means is if you give water enough time, water will pretty much erode anything, weather anything down into a very small particle. Now on this screen I've got a couple examples. The one on the left is kind of obvious. This is definitely an old car that's been left outside in the environment for many, many years. The iron in the car has reacted with the oxygen in the atmosphere. Water will help that process along. What's happened is basically the car is weathering the environment. It's chemical weathering, and it's breaking down that iron in the car into smaller pieces. If we would come back in 1,000 years, we probably wouldn't see much of that car, if any of it, if it was visible. On the right-hand side, that smaller picture of the gravestone or tombstone. That's a tombstone that's made out of a material called marble, a stone called marble, which was limestone, but through pressure and heat and time, that limestone's become a different type of stone, different type of rock. What's happened to that is there's been a chemical reaction that's occurred. If you notice, you can't really see any of the engraving very well that's on that stone. And that's because that chemical reaction has slowly eroded all the features off of it. When raindrops fall through the atmosphere, they pick up a slight amount of carbon dioxide and become a dilute, very, very dilute solution of carbonic acid. And that is what's reacting with that marble in that headstone. Now, for a couple local examples, we've got Cave of the Mountains, which is in Wisconsin. Some of you are probably familiar with it. It's a popular field trip destination. If you recall, if you were on the field trip, the water has seeped through the cracks in the limestone in the Blue Hills area where Cave of the Mountains is located, and it's eroded this area out. In other words, the chemical reactions are taking place on that limestone wall, and the water moving through carries that material away. The interesting thing that happens during this process is as that water is eroding and taking the material away, and that chemical reaction is occurring, breaking that limestone into smaller pieces, it's also dissolving something called calcite, which in this droplet here of the stalactite, you can see the crystalline structure forming. So even though it's opening up this cavern further and making it larger, it's also adding structures to it. When that water droplet falls down to the cavern floor, it still has some of that mineral in it, and it deposits the mineral on the floor, and it starts to create something called a stalactite. Now, in our activity, we're going to test different types of rocks to see which may and which may not be more suitable for chemical erosion or chemical weathering. So we've got several rocks that you're going to be looking at. You're going to take one of the rocks and place it in a glass tray or a plastic petri dish, and then you'll slowly add some drops of lemon juice or vinegar to the rock using a pipette or an eyedropper. We'll probably have vinegar, just so you know, and once you've added those drops to the rock, we're going to have a hand lens or a magnifying glass, and I want you to take a look at it very, very closely. If there's a chemical reaction taking place, you should see something like bubbles occurring. And if you do, think of baking soda vinegar reaction. That's essentially what you're looking for, and what's happening. You've got your observation sheet, your erosion worksheet that should have been shared with you in your classrooms. Try to note which types of rocks had that reaction occur on them. Talk with your partners. Why did that occur? What properties do those rocks have that you think this would occur in? And then when you're all done, dry the rocks off, set them off to the side so they can dry off. Pour out any liquid from the glass tray or the petri dishes that you're using, and then repeat the other steps with the remaining rocks. Hope you had a good time. Thanks for listening.